Welcome to the final session of our first module in refrigeration and air conditioning. In this session, I will learn more about the different types of aircraft refrigeration system. In the previous session, I have taught you the first very simple method of aircraft refrigeration system, and now on we will learn three more types. First one is simple bootstrap system, second regenerative system, and third one is reduced ambient cooling system. Okay, so first one, so this is a bootstrap system. So students, you can see here the ambient air is introduced to introduced into the aircraft, and what happened, ramming takes place. Okay, here it get rammed. So after this rammed air means its pressure is increased a bit. This increased pressure again enters our compressor, the main compressor. Main compressor will increase its pressure to a higher pressure. So students, this higher pressure air enters a heat exchanger. So since this air has got higher temperature, it should be cooled. It is cooled using the rammed air this bypass bypass to this particular heat exchanger. So what happens, from the air coming from the compressor will reject heat to the air, the bypassed air, so it gets cooled. Okay, so students, you have to note that here in Bootstrap, a secondary compressor is there. That is a specialty of Bootstrap system. So this cooled air is again compressed and increases pressure, and again it moves towards another heat exchanger. So here two compressor, two heat exchangers. That is specialty of Bootstrap. Okay. So this air again compressed in the second compressor is again cooled using the same bypassed air through another path. Coming, the rammed air is bypassed through another path to the secondary heat exchanger. So again heat exchange takes place. Thus the compressed air will get its temperature reduced, but the pressure will be same. So it will enter a cooling turbine. So the cooling turbine will reduce its temperature and pressure by expansion, and this reduced the air with the air hose temperature and pressure is reduced will enter cabin. So this cooling turbine is worked using the power provided by the cooling turbine will uh, the cooling turbine will give the work for the secondary compressor. Okay, the power required for the working of secondary compressor is provided by the cooling turbine itself. So this is how uh, uh, bootstrap system works. Okay, so we can see the TS diagram for this particular bootstrap system. So students, you can see here one, right, 1 to 2, what happens, ramming. So this is ambient air, 1 to 2 1 to 2 ramming takes place. Actually ramming is supposed to be an isentropic process, but actual ideal process is an isentropic process, but actually it is 2 dash is only possible, since it is not irreversible process. 1 to 2 is not possible, 1 to 2 dash, 1 to 2 dash, right? So this rammed arrow will be having the properties of 2 dash. From 2 dash to 3, the compression takes place, but actual compression is not reversible. So 3 to 2 dash to 3 dash, 2 dash to 3 dash. So here After compression, 3 dash will be the position of the state of the air. From 3 dash to 4, what will happen? Cooling. It is so from 3 dash, here also 3 dash, 3 dash to 4. So here, after passing through the secondary heat exchanger, it will be cooled to 4, right? So here it is cooled to 4 at, so this is a constant pressure, P equal to constant. Constant, since in heat exchanger cooling is taking place at constant pressure. So at constant pressure, 3 dash to 4, cooling takes place. So again 4 to 5 dash, actual process must be sorry, ideal process must be isentropic, but ideal process is not possible, so it is actually getting compressed to 5 dash, 5 dash. So after 4 it will get compressed for 5 dash, right? So again 5 dash to 6, what happens? Cooling takes place at constant temperature. So 5 dash to, so here 3 dash to 4, again 5 dash to 6 at a constant pressure. What happened? Cooling takes place. Now, so this now from 6 to 7, from 6, so here it is 6 to 7, what will happen? 6 to 7 dash, a cooling turbine is ideal process is isentropic expansion, but isentropic expansion is not possible, so isentropic, sorry, reversible, irreversible adiabatic process, adiabatic expansion is only taking place. So 6 to 7 dash, 6 to 7 is not possible, 6 to 7 dash. So 7 dash, what happened? Cooling takes place in cooling turbine. After that, the cooled air is then passed through the cabin. So cooling 7 dash must be at 5 dash to 6, 6 to 7 dash. So 7 dash be the pressure P, pressure at 7 dash should be equal to what? Cabin pressure. The pressure which should be maintained at cabin. So to 7 dash, cooling should be the pressure corresponding to 7 dash will be the pressure at cabin. So that line is called cabin pressure. This particular line is cabin pressure. Okay. So what happens? Ambient pressure. So this is ambient pressure. From ambient pressure, it is actually compressed reversibly like this, not isentropically. To 2 dash, again 2 dash to 3 dash. Sorry, this is not compression, ramming. Then again, after ramming, compression takes place. After compression, cooling in first heat exchanger. Then again secondary compression. After secondary compression, again cooling in heat exchanger. Then cooling in what? Our turbine. After turbine, it is cooled to the cabin pressure. Cabin pressure, heat is absorbed by this air from the cabin to some 8, position 8. So it will get heated, and this heated air is rejected outwards. So actually, it is not completing any cycle, right? So since it is not reaching the state 1 again, it does not complete a cycle, because air is available abundantly. So it is not needed, it is not necessary to recycle this air again and again. So that is why the aircraft operation does not form a cycle. Okay. So once we can absorb, we can take air from ambient or atmosphere, and we can reject this air after refrigeration to atmosphere again. So this air is not necessary to be recycled. Okay. So that is why it is not reaching the position 1 again. So this is the bootstrap system. In bootstrap system, what all things are there? Two heat exchangers and two compressors. That is a specialty of bootstrap system. Okay, bootstrap system has got two compressor and two heat exchangers. Uh, okay, you have to. So here, students, in heat exchangers, only temperature is getting lower. In cooling turbine, both the temperature and pressure is getting lower because we need pressure. We cannot provide high pressure air to the cabin. We have to maintain that cabin pressure level. That is why we are adding a cooling turbine at the end of two heat exchangers. By heat exchanger we can lower the temperature only, but if you want to lower the pressure also, you have to use some cooling turbine. Okay, so this is the idea of bootstrap system. So if you have to find COP here, COP is nothing but required refrigeration effect. Refrigeration effect is happening from MCP some T8 minus T7 dash, because refrigeration takes in place here only 7 dash to 8, right? And work will be the sum of these two works. Okay, sum of work in first compressor and second compressor. So things will be more clear when some problems are done. I will give you some problems as assignment. You try to do yourself. Okay, so that's it. Bootstrap system. Now we will move to next system, regenerative system. So, students, regenerative system is another kind of aircraft repair system where a concept called regenerative heat exchanger is used. Regenerative heat exchanger is used. The students here, ambient air comes enters the aircraft system and ramming takes place. Its pressure and temperature increases. After ramming, it will get compressed air is then again entered to heat exchanger. In heat exchanger, the temperature of the compressed air is reduced using the same rammed air bypassed. Okay, so this reduced heat, this air which has got its temperature lowered again enters another heat exchanger. So in this heat exchanger, heat is transferred. It will move in this heat exchanger and after cooling turbine. And after it reaches cooling turbine, it gets lowered in its pressure and temperature, and it gets the required cabin. It gets into a state which is required or designed to enter the cabin. So that is the refrigerated air itself. Now this refrigerated air is bypassed by some quantity again through this to the second heat exchanger. So it can reduce the temperature of the air coming from the first heat exchanger to to further extent. Okay, furthermore you can reduce the temperature. So that is why it is called regenerative. What's happening uh, after passing through the first heat exchanger? After passing through the first heat exchanger, I will show you. First heat exchanger, it flows through the first heat exchanger, its temperature gets reduced and reaches second heat exchanger. Okay, so in first heat exchanger, heat is transferred to the the rammed air bypassed through this particular heat exchanger. Okay, in the second heat exchanger, this heat is the air is rejecting heat to which air? This air is rejecting heat to the same refrigerated air exiting from the cooling turbine. Okay, exiting from the cooling turbine. So this is a cross flow heat exchanger. So the same cooled air coming from the cooling turbine is used to cool the air passing through the second heat exchanger. So that is why the name called regenerative system. Regenerative is used for this system. So students, the bypassed air coming from this first heat exchanger will rotate the cooling air fan. Okay, cooling air fan. So this cooling air fan, after by the rotation of cooling turbine, it will they set up the pressure required for the flow through this path. Okay, so that is happening here, and I will show you, the what I will show you the TS diagram here. So students, from one ambient pressure. So this is ambient pressure, right? At ambient pressure, it gets rammed to actual ideal ram pressure is higher than actual ram pressure. So it gets rammed to 2 dash. Ram pressure lower than the ideal ram pressure. Okay. 2 dash, 2 dash. So you can see here 1, 2 dash. From 2 dash to 3 dash. Right. So the 3 dash will have the same pressure but higher temperature, right? 3 dash, T3 dash is higher than T3. Why? Because the process is irreversible. Now from 3 dash, so you can here it is 3 dash. After compression, 3 dash. From 3 dash to 4, what happens? Cooling, constant pressure cooling in heat exchanger. Constant pressure 3 dash to 4, constant pressure cooling, right? Again 4 to 5, what happens? 4 to 5, 4 to 5 again, what happens? Cooling takes place. So 4 to 5, cooling takes place in second heat exchanger. So this is first heat exchanger, this is second heat exchanger. Again 4 to 5, constant pressure cooling takes place. From 5 to 6 dash, 5 to 6 dash, what happened? Expansion cooling turbine takes place, right? 5 to 6 dash, expansion from cooling turbine takes place. From 6 dash to 7, you can have one constant pressure heat addition in cabin. So 6 dash is the pressure of 6 dash is same as that of cabin pressure. From 6 dash to 7, what happened? The absorption of heat, extraction of heat from the cabin takes place. So this is the working of what? A regenerative heat exchanger. So here you have to take care that here two heat exchangers are there, only one is compressor, one compressor, and a regeneration. So this is a regeneration concept or process is taking place. Okay. Now if you want to find the COP and all, you can use COP. COP is nothing but required effect. Required effect is nothing but this is required MCP T7 minus T6 dash by work is nothing but here only compressor MCP T3 dash minus T2 dash. This is work. So if you know the temperature and all, you can find the COP. So this is regenerative heat exchanger. Now we will move to the final reduced ambient system. The students here air enters again in the same way as with the previous type. You get rammed. This rammed air gets compressed in the primary compressor and moved to heat exchanger. Okay. So the heat exchanger rejects heat into which air? The rammed air bypass, but the bypassed air is passing through a cooling turbine before entering the heat exchanger, so that its temperature and pressure is even lower than the original pressure. Okay, so cooling takes place from here to here. So the air gets cooled by rejecting heat to the rammed air which has passed through the cooling turbine, first cooling turbine. So more amount of heat can be rejected. Even better rejection of heat takes place. Okay. Now this cooled air passes through the second cooling turbine, so that it expands to the cabin pressure and temperature reaches the required level, and this cooled air passes through the cabin. Okay, and you have to note that the first cooling turbine and second cooling turbine are connected with the reducing air, hence it is known as reduced ambient system. Right. Right. So this air gets ejected through, uh, and a cooling fan is rotating in order to set up the pressure level, and this fan gets power from the cooling turbine. Okay. So this is reduced ambient system. The students here, students here you can see that there are two turbines, one compressor, one heat exchanger. So that's the difference from other systems you have already learned. So in Bootstrap system, in Bootstrap you can, I will show you. In Bootstrap system, two heat exchangers, two compressors, right? One turbine. In regenerative, you can see two heat exchangers, one compressor, and one turbine only. In reduced system, one heat exchanger, one compressor, two turbine. So that is the difference between all the three type. Okay. Now this is the graph, the TS diagram for which one? Our reduced system. The students you can see one from 1 to 2 dash ramming takes place from 2 to 1 to 2 dash ramming takes place. 2 to 3 dash what 2 to 3 dash compression takes place. 3 dash 3 to 4 dash what happened? Cooling. 3 to 4 cooling takes place, right? 3 to 4, 3 dash to 4, 3 dash to 4 cooling takes place. 4 to 5 dash, 4 to 5 dash what happened? Expansion takes place. 4 to 5 dash expansion takes place to the cabin pressure. 5 to 6, 5 to 6 It enters cabin 5 to 6. The heat absorption or the refrigeration in the cabin takes place. So this is the process of this is the property change or the TS diagram for the working fluid air in the reduced ambient system. So similarly in this case also you can find the COP by adding by taking the ratio refrigerated effect by work here. Only one work is required because only one compressor is used. If you have two compressors, for example, in case of Bootstrap system, you have to add, if you have to get total work, you have to add the work in both the cases, in both compressors. So that is how the working of different aircraft refrigeration systems takes place. So students, I will give you a problem as an assignment. So you try to solve that problem, and with this session I'm stopping this module. If you have any doubt regarding this module, you can ask me or you can contact me through any method, any platform. Okay, so I will give you a problem as an assignment. If you are not able to solve the problem, or if you are not able to understand that problem, you we can discuss that in Google Meet. Okay, I think I should arrange a session in Google Meet as soon as possible. So we have to ensure that things are clear to you directly. Okay, so I will intimate you about the date and time for the meeting. Okay, so with this I will stop this session. Thank you.